Hey guys, welcome back to my channel. My name is N Tejas and I'm studying in Sri Venkateswara College of Engineering, second year CSC branch. So, today's topic is stationary distribution of regular Markov chain and obtaining absorbing states. What is a Markov chain? A Markov chain is a mathematical system that transitions from one state to another based solely on the current state. This means the future is independent of the past. Let's dive into the probability of these transitions. Stationary distribution state. Stationary distribution is a probability distribution that remains constant over time. It tells us the long-term behavior of a Markov chain. Once reached, the probabilities of being in each state won't change. Finding stationary distribution. To find a stationary distribution, we solve the equation pi into p is equal to pi, where pi is the distribution and p is the transition matrix. This may sound complex, but it's like solving a fun puzzle. Let's explore some examples. Here is the example. So we have a transition matrix P which has 5, 4, 1, 2, 5, 3, and 1, 3, 6 as the this is the matrix. The From the above statement we have found that we have to use the equation pi into p is equal to pi. So pi is equal to x, y, z, and p is this following matrix. So pi into pa is equal to pi. The matrix x, y, z is multiplied with the matrix 5, 4, 1, 2, 5, 3, and 1, 3, 6 is equal to x, y, z. Now we multiply these two and equate it to the pi equation. We get the equations 5x plus 2y plus z is equal to x, 4x plus 5y plus 3z is equal to y, and x plus 3y plus 6z is equal to z. Now we should use all these three equations and we have to find the values of x, y, z. Next, let us learn about absorbing states. An absorbing state is a state that once entered cannot be left. Think of this like a black hole in space. Once you fall in it, there's no escaping. Identifying absorbing states. To identify an absorbing state, check if the probability of staying in that state is 1. If you can never leave, you have found an absorbing state. Let's look at some fun examples to clarify this. For example, here is a matrix P whose we have to check whether if it is in an absorbing state or not. To check if it is in an absorbing state, there are two main conditions for a matrix to be in absorbing state. The first condition is that the all the elements in this matrix should be non-negative, and the second condition is the sum of all the elements in a row should be equal to 1. For example, in row 1, the sum of the matrix is equal to 1. That is 0.4 plus 0.6 plus 0. That is equal to 1. Similarly, in the second row, the sum of the matrix is equal to 1. And in all the other three cases, that is 3, 4, and fifth row also, the sum of the elements is equal to 1. Hence, it is proven that the matrix is in absorbing state. Next, let us come into the applications of Markov chains. Markov chains are used in modeling stock price movement in finance. NLP algorithms such as finite state transducers, and hidden Markov models for POS tagging. Simulating sampling from complex probability distributions using Markov chain Monte Carlo method. It is used in economics, game theory, queuing theory, genetics, and finance. It is used in determining page rank by Google computing integrals of high-dimensional functions and analyzing consumer brand switching probabilities. That's it for the video. If you like the video, please do like, share, and subscribe the channel. Thank you.